All right. Ready. Okay, let's see here. Okay. Whew. So last day, we didn't quite finish one example. Right, we didn't quite finish this example. Oops. Oh. You guys presumably have it in your notes. Oh, we've got a bit of a lag here. Okay. So we're just going to finish this off. Right. Okay, so we introduced this idea of continuous compounding, which is a bit of a mind bender, right? It's not every day, it's not every hour even, it's not even every minute, it's continuously compounding, right? And so we can figure out what the future value is, even if we have continuous compounding. And we use that FV as the PV times e to the RT. Right? So last day we figured out what the future value would be. So you borrowed $7,500 13 years ago, right? And now you're going to pay it back. What you have to pay back is $10,380.23. The reason I say we didn't quite finish, right, is because what would be the equivalent annually compounded rate at which you borrowed this money? Right. So we can move between continuous compounds and annually compounded or weekly compoundings, right, to figure out what annually compounded rate makes 7,500 go to 10,380.23 over 13 years. Right. So now find the annually compounded rate. Bless you. That takes 7,500 to 10,380.23 over 13 years. Right? So we know, right, we need a frequency of 1, right, for annual compounds. And we're trying to find out what the rate is. N is time times the frequency, which in this case is going to be 13 years times 1, right? F, we're forcing it to be 1 now. So we have 13 compounds. It's all glitchy all over. Yeah. So we know our future value is our present value times 1 plus I to the power of n. We know we have to solve for I, right, the periodic interest rate, in order to solve for R. Right? So we know our future value is $10,380.23. And the present value must be 7,500 times 1 plus I, which we're trying to solve for, to the power of 13. Right? we want to try to shake out the I here, right, in an attempt to find R. Right, so we're going to divide both sides by 7,500, so 10,380.23 over 7,500 is 1 plus I to the power of 13. You could have just used your formula on your formula sheet for I, right? But like I said, I like to just start with the same formula always and figure out what I need to solve for. Right? But if you prefer to just start with the I formula, that's fine too. Right? So now we have 10,380.23 divided by 7,500. I get 1.3840306667 is 1 plus I to the power of 13. We need to ditch that power of 13, right? So we're going to take the 13th root of both sides. How do we take the 13th root of something? We rewrite the 1.384 as 1.384 to the power of 1 over 13, right? So on your calculator, you're going to enter 1.3840306667 to the power of 1 over 13. So this to the power of, and I put brackets around the 1 over 13, just to make sure they stick together. So to the power of 1 divided by 13, end brackets equals, I get 1.025315122 is 1 plus I, right? Now solving for I can just subtract 1 from both sides, so I get 0.025315122. I'll store this in 1. Because now, right, we want to try to find R, right? So now we know I is R over F. .025315122 is R over F, which is 1, so R is also 0.025315122. The annually compounded rate of, let's say, 2.53%, going to 2 decimal places, is equivalent to, what was the original question? To 2.5% compounded continuously. That's not that big of a difference, right? So it's kind of weird that something continuously compounding, right? It doesn't actually change that much, right? Versus an annual compounding of 2.53% is what we would need to get to that same future value, right? So there's not actually a huge difference. It's just kind of how we think about it is equivalent to 2.5% compounded continuously. So that's what we were supposed to finish last class, but we didn't. Okay. Any questions about that before we start with the practice test? Great. Practice test number 2, solutions. All right. So what I'm going to do, I'm going to start with the long answers first. Oh, confession time. I meant to have your assignment 1s marked today, but then I just had so many questions that I had to answer, so I didn't have time. And also, I didn't give myself enough time to mark them, I guess. So what I'm going to do is I'm going to send out an announcement on Moodle when assignment 1 and 2 are marked, because they'll be done this week. And then if you want them, you can come pick them up at my office and study from them over the weekend. Deal? Great. Phew, dodged a bullet there. As if you had a choice. Okay. So like I said, I'm going to start with the long answers because they're going to be the most important. Those short answers are really just to give you an idea of the length, right, to expect. The short answers can be any quick little questions from throughout this chapter 4 and 5. Okay? What's nice is test 2 is only on chapter 4 and 5, right? Simple interest, compound interest. Okay. Long answer questions. Right, we'll start with those. They're the important ones. Okay. So I've got here all of these questions. If you've been doing the assignments and just kind of been coming to class and looking at the notes and stuff like that, they should all feel familiar in one way or another, right? Things that might change could be simple interest or it could be compound interest, right? But the idea of the question is kind of the same all along, right? So for this one, we have 2 offers. We have to compare which one do we like better, right? We've seen one of those before, right? And so we calculate the value at some date for both of these, and then whichever has the highest value, we pick that one, right? So as far as the type, right? And you can expect to see this type of question, right? And that's what I mean. For the short answers, there's nothing rigid about it. For the long answers, yeah, you can expect to see this type of question where you're comparing 2 offers, right? So compare the value of 2 offers. So, okay. Rocky and Adrian have become real estate agents. Fun. They're selling their house and received 2 offers. I'm not sure they had to be real estate agents to sell their house, but whatever. 450,000 total, right? So in total, they have to pay 450,000 with 50,000 down. So 50,000 today, right? The down payments today, and 2 payments of 200,000 after 2 and 4 years. All right, so that's their first offer. Their second offer is a total of 475,000, right? But it only has 25,000 down, right, today, and then 1 payment of 450,000 after 3 years. So assuming a 6% rate of simple interest, right? So let's just make a note to ourselves. Okay, we've got simple interest. So now we zero in on the simple interest section of our formula sheet. Right? Which offer should Rocky and Adrian choose? Justify your answer. Include a timeline in your answer and use today as the focal date. Okay. So you also want to make a quick mental note. Okay, so today is the focal date. If you don't use today as the focal date, you will get this question wrong, right? Because I'm telling you which date to use. Okay. So let's map out offer number one. Let's do a timeline, right? We have to include a timeline, right? But I'm going to do a timeline for each offer, right? But what I like to do is I like to put all the dates that we need to consider on the timeline and then only use the ones for each offer. So what I mean by that is, so we've got a down payment today for each of these, right? And then offer number one has a payment after 2 and 4 years, right? So I would need 3 ticks for offer one, but I'm also going to throw in the 3-year mark because that's the one that I need for offer two, right? So what I'm going to do for each of these is the timeline I'm going to use starts today, and then I've got 2, 3, and 4 years. 2 years, 3 years, and 4 years. That way it's easier to compare the two, right? You don't have to put the 3-year mark on the offer number one. It doesn't really apply, but I like to have it there. Okay. So we draw our timeline, put the dates up top, right? And then we're going to jot down our payment amounts. So we've got 50,000 today, and then 2 payments of 200,000 after 2 and 4 years. I'm told that today, so use today as the focal date. What that means is that I have to draw all these payments and figure out what their total is worth today. Right? So this one's going to get pulled back. If I'm pulling it back, it becomes some principal amount or present value. If you want to call it present value and simple interest, that's fine too. Yeah. Because the focal date is today. So you have to pull all your payments to the focal date. Okay. And this becomes some P2. Okay. Adding these 3, right, the 50,000, P1 and P2, that's the total value today of offer number one. Total value of offer number one today. We need to put, this is simple interest, right? So we put the time on the arrows. So time between today and 2 years from now is just 2. And the time between today and 4 years from now, it's just 4 years. And we're also told that the rate for all of these is 0.06. Any questions about that one? So now let's map out offer number 2. Offer number 2, I'm going to put the same time stamps, I guess. I want it to kind of line up here. So we've got today, 2 years, 3 years, 4 years. So I had 25,000 down, so 25,000 today, and then a single payment of 450,000 after 3 years, right? So I've got this 25,000 today, And then I've got 450,000 in 3 years. Today is still the focal date. You have to compare the values on the same date, right? So pulling this 450,000 back to some P3, adding these up is the total value of offer number 2 today. Value of offer number 2 today. Simple interest, we put time on this arrow. The time is going to be 3 years between today and 3 years from now. And for good measure, I'll put R as 0.06 on here again. It's the same for both of these. All right. We would be able to deal with different rates, right, for each of these offers, right? But keeping it nice and easy here. Those are your timelines, right? So now we have these complete timelines. Now we can start our work. Okay. So P1, we want to solve from the future value is P times 1 plus RT. Okay. P is the future value over 1 plus RT. Just because we have to solve for P 3 times, right? We may as well solve for it in general, and then we can just use it. So P1 is the future value over 1 plus RT. The future value of P1 is 200,000. So 200,000 over 1 plus 0.06 times the time, which was 2. So 0.06 times 2 plus 1, I get 200,000 over 1.12. So P1 is 178,571.43, rounding to 2 decimal places right away. How about P2? P2 is the future value over 1 plus RT. The future value for P2 was still 200,000, right? They're the same. Over 1 plus 0.06 times 4 years, right? Nice. I don't know why it's lagging so much. Okay. So 0.06 times 4 plus 1, I get 200,000 divided by 1.24. Okay. You don't have to have this step that I keep doing, right? The 200,000 over 1.24. But if you want part marks, right, and you did something wrong when you're finding the denominator, right, it's best to show what you got, right? So 200,000 divided by 1.24, 161,290.32 pennies. So now we've got the total value of offer 1 is, I think it was 50,000. I'm reluctant to scroll because it keeps lagging. Plus P1 plus P2 is 50,000 plus P1, which is 178,571.43 plus P2, which is 161,290.32. 50,000, oops, 500,000. 50,000 plus 178,571.43 plus 161,290.32. 389,861.75. So that's your value of offer number 1 today. Just because they're putting off paying the 200,000 and the 200,000 for some amount of time, where we could have just put that 200,000, if we got it right away, right? We could have put it in the bank and gotten more than 200,000, right? So that's the value of offer number 1. So now let's find P3. P3 is the future value over 1 plus RT. The future value, oh, I wish I could remember, 450,000. And T is 3, I'll nab that while I'm here. Okay. So 450,000 over 1 plus 0.06 times 3. Thank you. Plus 1. So I get 450,000 over 1.18. $381,355.93. So now the total value of offer number 2 is, what was it, 25,000 plus P3. So I get 25,000 plus 381, 355.93, which is 406, 355.93. So then, right, I think we all agree, offer number 2 gets us more monies. So we would pick offer number 2. Another thing that we might ask is, what's the difference in the values between these two? Right. So offer number 2 is better with a difference of, so 406, 355.93 minus 389,861.75. Oof. $16,494.18. Kind of a big difference. Cool. Nice. Any questions about that one? No? Good. So that's simple interest, which by now feels pretty, we're pretty comfy in the simple interest realm, I think. So now, I'll just go steal a question. So, next long answer question. You're saving for a trip to Mexico. Or maybe it's a huge trip in Mexico. I don't know. You get the idea. You're saving for a trip to Mexico and decide you need $3,000 in 3 years. So you're going in 3 years. You decide to budget ahead by making 2 equal payments, one now and one in 2 years. Assuming an interest rate of 5% compounded weekly, what are your equal payments? I tell you, use a focal date of 3 years and include a timeline in your answer, right? So as far as the type of question here goes, right, you want to find unequal, or I guess they're equal payment amounts, find unknown payment amounts, right? In this case, we have this total amount that it has to add up to in 3 years. Right? So just find unknown payment amounts. And in this case, let's just make a quick note to ourselves. This is compound interest. Right? So now we're looking at the compound interest formulas, not the simple interest. And the focal date we have to use is 3 years. Okay. So we're going to start by making our timeline. So we're going to start today and we're going to end in 3 years. Okay. You're going to make a payment now and a payment in 2 years. Okay. So for these unknown payment amounts, right, in this case, we want them to be equal. We've got 2 equal payments. So what we do is we just denote that by using X here and X here. Right? And our whole goal to solve, so find the unknown payment amounts, is we use those X's there and then we can solve for X, right? Just like you did on the assignment. But I think on the assignment you had the third payment was 3 times as large as the second or something like that, right? So anyways, something like that. Can't remember. Okay. All right, so we're told to use 3 years as our focal date, which means we have to pull all our payments to 3 years. Okay. So this little guy gets pulled forward to some future value 1. And this little guy gets pulled forward to some future value 2. These have to add up to 3,000. Right? At 3 years, I need to have 3,000 in the bank. Let's jot down. So we've got a rate, I'll just put it down here, of 0.05. And a frequency compounded weekly, so the frequency must be 52, right? From here, I can calculate I for all of these. I is R over F, which is 0.05 divided by 52. 0.05 divided by 52, I get this teeny tiny answer, 123,961,538. And you know what? I'm going to store this in 1. just so I don't have to keep typing it out all the time. To complete this timeline, right, I have to put the number of compoundings, because we're talking compound interest, on each of these arrows, right? So n is time times the frequency. The time length of this arrow that I'm on is only 1 year, right? Between 2 years and 3 years. So it's 1 year times the frequency of 52. So I've got 52 compoundings in there. This next one, I've got n is time times the frequency again. The time between today and 3 years from now is 3 times 52. I get 156. Now we have this complete timeline. Yeah. Well, you need I in your future value, right? Yeah. So I put the next step in bracket 1 plus 0.05. Yeah, you can. If you want. Sure. Same for n. You could replace it with t times f. But I want to see it on here anyways. Yeah. So it's compounded weekly. And so weekly compoundings, there's 52 weeks in a year. So we get 52. Okay. Cool. All right. Now we can get to work, right? We have to find future value 1 and future value 2. Future value 1 is PB times 1 plus I to the power of n. Our present value, we don't know it, right? But we can just use x as our present value, right? And that's how we're going to get x into our equations. So we get x times 1 plus 0.00096153.8. Good thing I stored that. To the power of the n for future value 1 is 52. So if I go 1 plus recall 1 equals to the power of 52, I get 1.0512458442 times x. And I'm going to store this in 2. Okay. Now we can solve for future value 2. Future value 2 is the present value times 1 plus I to the power of n. The present value, again, is just x, right? They have to be equal payments, so we just use x times 1 plus 0.00096153.8 to the power of 156 this time. And so I've got 1 plus recall 1 equals, and then to the power of 156, I get 1.161750513 times x. For good measure, I'll store this in 3 just in case I need to lose it. Yeah.
I got 1, 7, and the future value 1, 5, 8, 1, 7.
Okay. Is anyone else getting different numbers? Yeah. Do you have the I is 0.05 over 52? And you're not rounding it? You stored it? And you've got n for the first one's 52 and n for the second one's 156? We can have a look later. Where are you getting these 1, 7 on the end?
Instead of the last one.
Here?
Yeah.
1, 7. We can have a look at that. But yeah, give it a run through. Is anyone else getting 1, 7 on the end there? Yeah. Okay, so we've got 4, 2. We've got 1, 7, 4, 3. Any takers?
1, 6, 1, 7, 5, 0.
Is that for the second one? Let me check my notes here, but I'm pretty sure. Yeah, that's what I have in my. I have this in my notes too. So just check, and then maybe let's double check your calculators. So you've got 1, 7 as well. How many decimal places are you showing? Is it 9?
I have exactly this, yeah.
Yeah.
Okay.
After the 5, I have 0, 4, 3, and you just say it now.
That's not what I got.
So you should be doing, so I saved my, I'll find my I first. So 0.05 divided by 52. I'm going to store that in 1. Okay. And then I'm going to do 1 plus recall 1 equals to the power of 52. I get the same as what I have. Well, I figured I'd just check both of them maybe. Because we've got discrepancies in both, I think. But I'm still getting the same answer. And then 1 plus recall 1 to the power of 156.
You know, I think there are more decimals that are showing on the screen. So if you do 0.05 over 52 to store that, you'll get a different answer than if you type 0.05. Yeah, exactly.
Oh. Okay. Okay. So, okay. If that happened on the test, obviously I'd be like, no, everything looks good. I'd follow through. But it sounds, yeah, that sounds reasonable. So if you're just using this value instead of 0.05 over 52, you're going to get slightly different.
Awesome. So
It's like solved. Phew. Get it off my desk. Okay, so now let's solve for these unknown payment amounts. Okay. All right. So now we know that the total has to be 3,000. 3,000 has to equal future value 1 plus future value 2. So now we've got 3,000 must equal 1.0512458442x plus 1.161750513x. Luckily, I've stored those in 2 and 3. So recall 2 plus recall 3. I get 2.212996355x. Right? Because those two both have x's on them, so I can just collect like terms. And all along here, they have to equal 3,000. No, so if we had an x on its own, then yes. But in this case, because we only have this, so if we had an x here, then we would have to add that. But because we only have payments here and here, so now we can finally solve for x. X is 3,000 divided by 2.212996355. So X must be, and these are dollar amounts, $1,355.63. And that's good enough for me, right? They're equal payments, right? So the equal payments amount, equal payments must be 1,355 and 63 pennies. Something like that. Right. So 1,355 and 63 pennies today, and another payment, what was it, 2 years from now? Those will grow to total 3,000 in 3 years from now. Okay. Any questions about that one? Okay. Let's go on to the next long answer. Oops. This is you guys. After all this investment talk in math class, you decide to go to the bank and find an investment for a $2,000 tax return you receive. Sounds nice, right? The bank gives you two investment options. The first one is an interest rate of 6% compounded bi-weekly for 1 year. Okay, so you're only investing it for 1 year. The second option is a simple interest rate, which starts at 5% for the first 7 months and then becomes 8% for the last 5 months. Right? Which investment option should you choose? Justify your answer and include a timeline in your answer. Okay. So which of these is going to be better? Right, so we're going to deposit $2,000, and whichever one yields the highest future value, that's the one we pick, right? So as far as the type goes, compare interest rates. So we've got, well, first thing we should keep track of, right? Option 1 is compound interest, and option 2 is simple interest. Well, you can't do that to us. I can, and I will. Okay. So, all right. Option 1. I'll just make a note to myself here that we have compound interest. Right. And just jotting down the information that we have, R is 0.06 and the frequency is bi-weekly, so that's 26, right? That's one of those that you have to remember. So you want to invest this for 1 year. So we want to invest $2,000. It's going to grow to some future value. Let's call it future value 1 for option 1. This is compound interest, right? So we have to put our n on our arrow. N is time times the frequency. The time for this one is 1 year, right? 1 times the frequency of 26. So we've got 26 compoundings. For compound interest, I have to find I. I is R over F, which is 0.06 divided by 26. Oops. 0.06 divided by 26. 0.00230769. I'm going to store this in 1. Should we just find the future value of option 1 before we do the timeline for option 2? Why not? Future value 1 is the present value times 1 plus I to the power of n. Usually we would have done the timelines and then the calculations, but it doesn't really matter. 2,000 times 1 plus I, which is this 0.00230769. Oops. To the power of n, which is 26. So plus 1 to the power of 26. I get 2,000 times 1.06176315. Yeah. Times 2,000. So this is going to have a future value of $2,123.53. Yeah. Well, they would be. I'm just solving them separately, right, to show the complete timeline. But yeah, you could replace I and N with I is R over F and N is T times F in your formula. Well, yeah, but you still have to show your work up above, right? Yeah, but it, of course, it'll give you the same thing. Okay, so if that's what you like, do it. Okay, so now let's look at option 2. Option number 2, remember, is simple interest. Okay? And we've got a changing interest rate, which we know how to deal with, right? But we've got a simple interest, which starts at 5% for the first 7 months and then becomes 8% for the last 5 months. Okay? So we've got simple interest. We start today and then 1 year. For the first 7 months, was it? Our 2,000 is growing at a rate of 0.05, right? And the time for this little guy is going to be 7 over 12. And then the rate changes for these remaining 5 months. Right, and they're 8%. So here we've got a rate of 0.08 for a time of 5/12. So here we get future value of option 2. With these changing interest rates, you have 2 options, right? You could figure out the amount of interest, right? Here, I equals PRT. And then the amount of interest after this one, and then add them up, right? Or just use that changing interest rate formula that we have. I think that's easier, right? So here we have the future value is P times 1 plus R1 T1 plus R2 T2. Hopefully I remembered that right, because, yeah, I forgot my formula sheet. So now if we think of these R and T's, if I put a little subscript here, R1, T1, R2, T2, right? They're just referring to which interest rate period we're talking about. So now we've got 2,000 times 1 plus 0.05 times 7/12 plus 0.08 times 5/12. I'll do 7/12 times 0.05. Jotting these down, I get 2,000 times 1 plus 0.02916, repeating. I'm going to store this in 1. I don't think I need 1 anymore. So store in 1 plus 5/12 times 0.08 is 0.03, repeating. I'll store that in 2. So I've got 2,000 times 1 plus recall 1 plus recall 2, 1.0625 even. Imagine that. It's almost as if it was planned. So now times 2,000, I get a future value of 2,125 even buckaroos. So comparing these, I guess this is future value 2. Comparing these, right? Trying to squeeze them on the same page here. Option 2 is ever so slightly a little bit better. So we would go for it probably, unless you want to brag about having compound interest on your investment, then you should go for option 1. Unlikely. We would pick option 1 as it is what, $1 something minus 2, 1, 2, 3. Oh, what the option? Yeah, sorry. No, I'm trying to force option 1 down your throats. As it is 0.53, $1.47 better. It's still $1.47 in the bank. Hello. Okay. Okay. I think I'm still recording. Okay, good. Not sure why I did that. Okay. So, any questions about that one? All right, so compare, you're given two interest rates, some initial value, which one's better? Right. Your last long answer is one of these sneaky ones where we've got an original agreement plan or agreements payment schedule, whatever. And then we miss a payment, so we have to restructure the loan and we have to figure out what the equivalent payments might be. Right? So this is probably the beast of the test, right? So as far as the type goes, I'll call it a restructured loan, right? You have some original loan payment plan, you have to restructure it, find the equivalent payments. Okay. So Ralph takes out a loan from Sydney. They agree that Ralph will pay $2,900 after 3 years and $4,200 after 6 years, with 7% interest rate compounded monthly. Right? So we'll just make a note here. We're compounding. Ralph, of course, misses the first payment and wishes to restructure the loan payments with one payment after 4 years and double that payment after 5 years. Let's say, I'm going to just clarify here. Okay. After 4 years from the original agreement date. Okay. So this new payment plan is still from the original agreement date. So we're going to restructure this loan with one payment after 4 years and double that payment after 5 years. What should Ralph's payment at 5 years be? Make the focal date 5 years and include a timeline in your answer. So we've got our timeline. And we've actually got 3 years. Let me just double check to make sure that's what I did. Oh. So the original payment, right, and it might be helpful to just jot down these dates, right, just somewhere so you can kind of sort them out in order, right, before you put them on the timeline. So we've got today, right? We need some sort of reference point, right? And so the original payment, he's going to make a payment after 3 years and 6 years. Okay? And then he's going to make a payment after 4 years and 5 years, right? So we've got 5 payment dates or dates that we care about. So then we need 1, 2, 3, 4, 5. So we've got 3 years, 4 years, 5 years, and 6 years. So these ones, I would say this last question and the last question on the test is going to be the hardest one, right? Because it is going to be something like this. So we have to kind of figure out how many dates we have, right? And then map them out. And so let's see here. We're told to use a focal date. So I'll just highlight that here. 5 years. Oops. So this here is our focal date. And so the old payment schedule was to pay $2,900 after 3 years. Oh, I'll move this old up one line. And $1,200 after, or $4,200, sorry, can't read up there. $4,200 after 6 years. So these are going to be worth something at the focal date. Right? So that's the first thing that we need to figure out, because this was the original payment plan, right? And so we get some future value 1 and some present value 2. The subscripts now are denoting which order I'm calculating these things. Between this future value and present value, it doesn't matter which order you do them in. I just move from left to right. Okay. So this is the total value at 5 years of the original payment schedule. So this is the total value at 5 years of original payments. Now he's suggesting a new payment plan. He's saying, okay, well, I missed this one at 3 years, right? The $2,900. Okay. And so I want to make one payment after 4 years and then double that payment after 5 years. Right? And so what we do is we show, okay, so now we have our new payment plan. We could put them all on the same timeline, right, and have them all mush up, but it gets a little messy, right? So I just make another kind of layer. Okay, so he wants to make an unknown payment at 4 years and then double that payment at 5 years. So we show that by 2x at 5 years. Okay. So now this x, we have to calculate the future value 3, but 2x plus future value 3 is going to be the value, the total value at 5 years of the new payments, right? Which, if they're going to be equal, they have to be the same. Those totals have to be the same. So this is the total value at 5 years of the new payments. I'll just jot down some information that we need, right? What do we need? We need the rate and we need F, right? Because we've got compound interest and the rate is 7% compounded monthly. Right? So just kind of putting it down here, the rate is 0.07 And the frequency is monthly, so we've got 12. We can calculate I as R over F, which is 0.07 over 12. 0.07 divided by 12, oops. 0.083 repeating. I'll store that in 1. The only thing that's missing now is my n on each of these lines. Right? N is say that again. 5.0.
0.005.
Oh. 0.07 divided by 12. Sure is. Not sure how I got that one. Thank you, thank you. 0.00583 repeating. Now we'll store that in 1. No harm, no foul. Okay. Now I can fill in, now I can get to the easy stuff. Fill in my ends on these lines. The time between 3 years and 5 years, I'll go ahead and say 2 years times a frequency of 12. So my n for this one's 24. Here, I don't have that much room, so I'll just say 1 times 12 is 12. If I have room, I like to show off that I know that n is time times the frequency. If I don't, I just get to the chase. And then same thing here for 4 to 5 years, we've got an n of 1 times 12, which is 12. We know, right, that the total value of old, right, or the original has to equal the total value of new, right, at 5 years. Okay. Right, because what we've started to notice, right, is to find these unknown payment amounts, you have to know what they have to add up to, right? But the only way to get that is to figure out the original value of these original payments, right? So we need this total value, and then for them to be equivalent, this value is the same as this value, and that's how we'll solve for the unknown payment amounts. Okay. So let's find some future values, some present values. Future value 1 is present value times 1 plus I to the power of n. The present value here, I think, was 2,900 times 1 plus 0.00583 repeating to the power of, what did we say, 24? Yeah. So plus 1 to the power of 24. I get 2,900 times 1.149806017 times 2,900, 3,334 and 44 pennies. Just got right to it. I know, it was tempting. So now let's find present value 2. Present value for compound interest, we have the formula on our formula sheet, so we can just go ahead and use it, right? So it's the future value over 1 plus I to the power of n. The future value is 4,200 and n is 12. 200 over 1 plus 0.00583, repeating to the power of 12. 1 plus, recall 1, to the power of 12. 4,200 divided by 1.072290081. 4,200 divided by that guy, I get 3,916 and 85 pennies. So then we know that the total value of the original payments at 5 years is future value 1 plus present value 2, which is 3,334 plus 3,916.85. $7,251.29. Okay, so now we know that these unknown payment amounts have to add up to $7,251.29. So now we can find future value 3. Future value 3 has a present value of x. Wait, where? Okay. Future value or present value of x, and the n is 12. So future value 3 is the present value times 1 plus I to the power of n. Present value, oh, still catching up. That's where I am. Present value is x times 1 plus 0.00583, repeating to the power of 12. 1 plus, recall 1 to the power of 12. I get 1.072290081 times x. I just like to write the x after. Cool. So now we know the total old has to equal total new, right? And so what we're saying is that 7,251.29 has to equal 2x plus future value 3. This becomes 2x plus 1.072290081x. So you've got this 1.07 on your calculator, so just add 2. So we get 3.072290081 times x. All along these equal 7251.29. Oops. 7251.29. X must be 7251.29 divided by 3.0722900081. So 7251.29 divided by the previous answer. I get an X of 2,360.22 pennies. Therefore, the payment at, what was it, 4 years? I'm afraid to scroll. Oh, we have a payment at 4 years and a payment at 5 years. Therefore, the payment at 4 years must be 2,360.22, right? And the payment at 5 years, right, was 2x. Must be that times 2. Oh. 4,720.44 pennies. Nice. Long answers. Done. Let's rattle off some short answers. How about? Any questions though about that one? So by far the most complicated. Yeah. So, oops. The short answer problems. For short answer For short answer problems, you don't have to show any work if you don't want to. Oops. Oh, they got. You can get part marks if it ends up being wrong. Yeah. So that's the only reason that I would say show your work. But if you're confident in your answer, then you don't have to show any work. It's logged me out. Okay. Let me see from iPad. Sure what's going on here. It's like it was sick of the long answers as well. Let's see here. There we go. Oh, what's that? Okay. So we'll just do a couple and then I'll post all the solutions later. How about? But for this one's a calculator one, so I just want to make sure that everyone's okay with the days between dates because those are going to be easy marks, right? So here we're going to have date 1 is September 4th, 1951. So we had to put our dates in month, dot, day, year. Thank you. Thank you. Nice. So then I think if we put in 51, it should know that we mean 1951. I know, apparently it doesn't. No. It reckons we have no business going there. It's really weird. Good question. It should be it was very short-sighted. Please email Texas Instruments and let them know. They'll be like, fine, but you'll have to buy a new calculator. Yeah, I'm sure someone got in trouble. It's pretty short-sighted, actually. I don't know. But date 2 is going to be October 31st, 2012. So October is what, the 10th month? 31st of 2012. So now we want to find our days between dates. Put a star next to it to show that I found it. Nice. Okay, I'll check my work against yours. So I get 09.0451, enter. 10.3112, enter. Scroll down, days between dates, compute. It's gonna feel good. 22,338. But if you just put down that guy, the 22,338, that's a whole mark. Moving on. So you don't have to show your work. For me in the solutions, I'll show all my work so you know where it came from, right? Okay. Oh, let's see if there's any fun ones. Were there any tricky ones in the short answer you want to tackle? Or should I just post the solutions later? Well, not together unless you want to. I sense restlessness. Pardon? I? Which one? D as in David? E? I'll kind of pick and choose here. So E, I've got by request. It's so laggy too. That's what's so annoying. So here, right, we've got a future value and a present value. We've got time and we want to find R. So we're given the present value. Just make a quick note, right? We're compounding. Wait for it to. It's really annoying. Right, so we've got compound interest. So we've got a present value of, is it 30,000? That's the commas, I can't tell. Future value of 50,000. Yeah. And time is 10 years. And we want to find R. Oh, and I guess we're also given our compounding frequency. F is monthly, so we use 12. No, because we're compounding monthly. So now we can do the future value, or actually, you want to find R. Should we just use your formula for I on your formula sheet? Yeah. Yeah. You could also use your calculator. You've got options, right? We'll do it by hand, but you could use your calculator too, right? So then we need N is time times the frequency, which is 10 times 12, 120. So then let's use I. I is what the nth square root, or the nth root of future value over the present value, all minus 1, right? So I is going to be the 120th root of 50,000 divided by 30,000, all minus 1. So just doing these kind of rashly on our calculator, 50 over 30,000 to the power of 1 divided by 120 in brackets, and then all minus 1, 0.004265954. Yeah, so you're going to do 50,000 divided by 30,000. And then to the power of 1 over 120, right? To solve this, you're going to do 50,000 over 30,000 to the power of 1 over 120. And then subtract 1 from that to get your I. So then I is R over F. I we know is 0.00426595, which is R over F, which is 12. I have the 0.004 on my calculator still, so I can multiply by 12. And I get R is 0.0511914443. So the nominal rate is approximately 5.12%. Monday.
Is this coming from like calculation or something? Yes.
Just do it now. Okay. Does that sound good? And then we had a request for I. I's a little sneaky. So we had a request to do I. Using the rule of 72, roughly how long would it take for an investment to quadruple its value if the rate of interest is 6% compounded weekly? So here, the doubling time is roughly 72 over 6. 72 over 6, roughly 12 years. So then the quadrupling time is roughly 2 times 12, 2 times the doubling time. Years.
How does that not change depending
With the compoundings? I was gonna say,
whether it's compounding?
it does, it is gonna change, but what I'm doing, so because we're just doing an approximation, I'm just gonna use the approximation and ignore the compoundings. But yeah, good catch. Yeah. Oh, because the 12 years is the doubling time, like our formula gives us the doubling time, right? So you wanna double the doubling time. Can't do. No. Yeah, we can move in multiples of doubling time. Yeah, we could technically, if you wanted to be proper, you could convert the 6% compounded weekly into an annual rate and then move back. But you'd get roughly 24 years anyways. But yeah, so for this using the rule of 72 question, just use the rate 72 divided by that rate. Cool. So what I'm going to do is I'm going to go through, I'll go back to my office, I'll go through and make the solutions for the rest of them. And then you'll have them all. But let's pack up shop. Let's get out of here.
Practice this marks.
Pardon?
Oh, practice this marks. I did like some 2 window answers.
Oh yeah, I told you to remind me after. Hang on.